afternoon, all of you. My name is Harshvardhan. I am tech scholar from Delhi College of Engineering, and my paper topic is experimental investigation on optimization of aluminum grade 5083 and 6061, which were welded using TIG welding. And the co-authors are Professor A.K. Madan sir and MS Ninjan sir. So let's come to the introduction first. So as new automobile sector and rail coach factories, shipbuilding industry aim to design their vehicle to reduce the weight without compromising with strength and safety standards. So one of the metal which comes under the lights of metallurgists is aluminum due to its weight to strength ratio and availability on the earth. As use of aluminum grows in the industry, new challenges arises. One of them is joining two different grades of aluminum due to their difference in thermal conductivity and melting points. So for aluminum, generally FSW and laser beam welding are majorly used because of their high weldability and less defects are formed in this process and good mechanical properties are obtained. But in case of FSW, the filler joints can't be prepared, and but in case of laser beam welding and the crack due to the rapid cooling, cracks may be formed. So GTW process is one of the MEM which provide the desired properties in less complex shape and low initial cost. So the material that we use is two different materials, aluminum 5083 and 6061. So 5083 were in annealed condition and 606 were in tempered hardness condition of at level 6. So 5083 is have the highest strength among the non-heat-treatable alloys, and due to the high resistivity toward the atmospheric attacks and corrosion, this grades of aluminum is known as the marine grade of aluminum, where it comes on 6061. This is belong to 6 series of aluminum alloy where magnesium and silicon are major alloying elements. So in due to which the machinability and weldability of these material is very high, and the mechanical properties of 6061 is also very high. So now come to lecture view. So I will discuss only one day due to time constraints. So let's come to the main. One of the researcher from New Zealand who works on the welding of two dissimilar aluminum alloys using GTW. In his research, they found that to get the optimum result, the welding torch should be placed over the metal, which has the higher thermal conductivity. And to avoid the head cracking of the material of dissimilar metals, filler materials must be used. Even the thickness of the plate is less than 3 mm. And in reduction of heat affected zone, he found that in case of 6 series aluminum, the natural age conditions of aluminum alloys have less decrease in the value of strength in heat affected zone as compared to artificially aged. So the research gap that we found in our study is that in TIG welding of aluminum alloy, most of the researchers are done the welding on same material. Very few of them have worked on the dissimilar metals. And the second thing is that in the testing part, that most of the researchers are limited to the tensile testing only, but very few have worked upon the micro hardness tests and other processes. So in the case of welding of dissimilar alloy, so the V-shaped butt joint has been prepared with a root gap of 3 mm. And the most important factor that we have included is the use of different filler materials. So in this study, 3 different filler material has been used to make the V-shaped butt joint between 2 different grades of aluminum alloys. So the objective of this study is to aim the optimize the process parameters that we use in our TIG welding process using Taguchi method, and to identify the parameter under which the variation of mechanical property is being seen with the low M peak values, and to form the sound weld under the various process parameters, and perform the both non-destructive and destructive tests, and find the most dominating factor in case of tensile properties of material and micro hardness tests. So come to the experimental part. So as we discussed above, 2 base metals has been selected in the study. One is 5083 and 6061. In case of 5083, magnesium is the main alloying element. In case of 6061, magnesium with silicon is main alloying element. So comes to filler part. Those three different fillers has been used. The first one is 4043, which are mainly used for welding 6 series of aluminum alloy. Next come to filler 4047, which are known for silicon richness, and third one is 5356, which are mainly used for welding 5 series of aluminum alloy. Now come to the preparation part. So the aluminum plates has been prepared in dimension of 110 in length, 60 in breadth, and 5 in thickness using the shearing machine. And V-shaped butt joint has been prepared using the grinder wheel with maintaining the 2 root cap, and the thick welding process has been done. So the process parameter that we have studies is welding current, shielding gas flow, and filler material. So now comes to Taguchi design matrix. So Taguchi align orthogonal array has been used for the optimization of these process parameters. So in Minitab software, so at three levels and three factors. The three factors are welding current, filler material, shielding gas flow, and three levels are for welding current is ranges from 180, 200, and 220 ampere. For filler material, as we discussed, over three different fillers has been used. For shielding gas flow, three different levels of gas flow has been used. So starting from 10 liter per minute, 12 liter per minute, and at last 14 liter per minute. So now these samples has been prepared according to the design matrix of Taguchi, and the argon is used as a shielding gas for the shielding of the arc between the non-consumer electrode and workpiece. So these for now come to testing part. For tensile testing, the specimen has been prepared on SolidWorks, which have design has been discussed here in the figure below, and the standard is ASTM E8M standard, under which the specimen has been designed, and the extraction of the specimen has been done from the plates are using the EDM wire cut method. So at the right, these are the nine specimens which were tensile tested. So universal testing machine has been used with capacity of 50 kilonewton, and the cross head speed of 2.5 mm per minute has been used for tensile testing for each sample. Now to the come to micro hardness part, so the specimen has been taken from the welded joint, where it comprises 5 zones, so 2 base metals, 2 heat factory zone, and 1 weld beads. So the specimen has been cold mounted, and the polishing part has been done using the different grades of waterproof sandpapers from ranges from 100 to 2500. Then the polishing is completed. After that, the wicker indenter is used for the micro hardness test with that load of 500 gram and dwell time of 10 seconds. So in total, 3 indents has been taken in each zone. So total 15 indents has been taken on a one specimen. So at right, you can see the micro hardness testing machine, which the indenter is wicker hardened indenter. So now come to result and discussion. As total 9 specimen has been tested. So in case of tensile testing, the highest value UTS value that achieved is 182 megapascal. In case of specimen which have the parameters such as the filler material 5356, welding current 200 ampere, and shielding gas flow 12 liter per minute. So while in other filler materials, in case of 4047, the highest value UTS value that we achieve is 179 megapascal, and in case of 4043, the value is 149 megapascal. So these are the tested specimen. So the fracture has been found in the heat factory zone of the weaker material. So majority of specimens has been failed from this reason, and few of them failed from the value reason due to less penetration. And these are the stress strain curve of 3 different specimens comprising 3 different filler materials. The optimum specimen has been used for the preparation of stress strain curve. Now comes to macro hardness analysis. So wicker indenter has been used with a dead load of 500 gram and dwell time of 10 seconds. So at right, the indent can be seen in picture in right. So The highest value of Wicker hardness value is achieved is 84 HP 0.5. 0.5 represent the dead load, that is 500 gram, which is on the sample which comprising the filamentary of 5356. And in case of two different fillers, that is 4043 and 4047. In 4043, the highest hardness value is 66. In case of 4047, the highest value is 81. And uh, as right, we can see the profile of the hardness. So which comprising three zones, that is two heat reactant zone and one weld zone. So we can depict that the hardness value, high hardness value is seen in the weld zone. And now comes to Taguchi analysis. So Taguchi analysis has been done on both tensile testing and micro hardness tests. So the in case of tensile test, the most dominating factor is welding current, which has the rank 1, and then followed by the filler material, and then at last shielding gas flow. While in case of micro hardness test, the main dominating factor is filler material, followed by welding current, at last shielding gas flow. So these are the mean SN curve for the both micro hardness for tensile test and micro hardness. For the highest is better design Taguchi matrix. So the optimum value that we achieve is in case of tensile testing, it welding current 200 ampere, filler material 5356, and shielding gas flow 12 liter per minute. While in micro hardness, the optimum value is for welding current 200 ampere, filler material 5356, and shielding gas flow 10 liter per minute. So now come to conclusion part. The in case of tensile testing, the optimum value of 182 megapascal is achieved in a specimen with the filler material 5356 and welding current 200 ampere and shielding gas flow 12 liter per minute. And in case of other two materials, as we discussed above, the highest UTS value is in case of filler material 4043 is 149, while in 4047 the value is 117 megapascal. While it comes to the hardness part, the Wicker hardness value that we achieve is highest value achieved is 84 in case of specimen with filler material 5356. So according to the Taguchi optimization methods, the most dominating factor in case of tensile testing was welding current. And while in case of micro hardness, the most dominating factor is filler material. Thank you.
Thank you for your presentation.